In this video we will compare the result of heating demineralized water using a microwave oven and an infrared stove. Both methods allow us to boil water in a smooth glass container, which is required to produce superheated water. Let's use the glass from our previous experiment using microwave oven. Now it's on top of an infrared stove. Let's pour demineralized water into the glass. I'll start the heating at 800 watt. I can't go much higher since it could trip the circuit breaker. After a few minutes the stove glows red. It's unfortunate that the glass has cracked. Some water leaked out from the glass. The leakage gets worse. Even when the power has been turned off, the stove is still hot enough to evaporate the water on its surface. Let's see the condition of the glass. It has been broken into two pieces. So we need to use heat-resistant glass for our experiment, like a borosilicate beaker here. Let's pour the demineralized water into it. We need to make sure that the new glass is smooth enough to produce superheated water. Let's set the power level to high and heating timer to 2 minutes. Around 30 seconds before the timer is up, we can see the water has boiled. Let's check if it has been superheated using a fork. The bubbles show that it has. Let's continue the heating process. When the door is opened, the water seems to be boiling. Let's check if it has been superheated using a fork. The bubbles show that it has. Now we will try to replicate previous result using this infrared stove. We already know that smooth surface and water purity are required conditions to get superheated water. This experiment will tell us if they are adequate. Let's heat the water at 800 watts power. After around 5 minutes, the water is boiling. Turning the stove off doesn't stop the boiling, since the heater is still hot and emitting infrared light. So let's move it out from the stove. Let's check if it has been superheated using a fork. No bubble shows, which tells us that it is not superheated. Let's repeat the last experiment to make sure that the result is reliable. Let's check if it has been superheated using a fork. No bubble shows, which tells us that it is not superheated. We also try to heat the water using this 300 watts hot air gun. Some water from the surface seems to evaporate, but it doesn't seem to boil from the hot spot. Let's put the beaker on a grid, so we can heat it from below. It doesn't seem to help much. The conclusion from our experiments is there's something in microwave is needed to superheat water, which can't be provided by other heating methods like infrared stove.